All right, Harmony Science Academy students. AP Calculus specifically, we're looking at section 3.2. So let's go and get into it. Again, this is what essentially it looks like to get into an exercise problem and put to use what you guys are about to read and learn about. So let's get into it, okay? In this exercise, it reads like this. Determine whether Rolle's theorem can be applied to f on the closed interval AB. If Rolle's theorem can be applied, find all the values of c in the open interval AB such that f prime of c equals 0. Okay, and we're given f of s equals sine of x in the closed interval 0 to 2 pi. Okay, so there's a lot going on here. If you're looking at this for the first time, it's intimidating until you read this section and get familiar with Rolle's theorem. Okay, so where do we start from here? The first thing, and we want to have one approach for all these problems, okay, is you want to investigate, is there even a point where you've got this occurring? Okay. You get that from the reading, okay? So essentially, if you plug in two different values in this interval into sine of x, will you get the same y value, okay? Which, again, I like to pick these trigonometry problems to force us to look at trigonometry. In class, we may not have you work on trigonometry, but I think it's good for me to at least give you guys that refresher, right, from pre-calculus. So anyways, we would know, okay, off the top of our heads or with a little thinking, that when you plug in 0 to sine, okay, you do get the same as 2 pi. Okay, so you definitely want to investigate these two in there first to see if they're equal. So it's almost like we've got a question mark. And sine of 0 and sine of 2 pi is 0 equals 0, so they do match. Okay? So again, in case you're a little lost, remember on that unit circle, alright, you've got the coordinates 1, 0, here you've got 0, 1. This is very fundamental but very important. You've got negative 1, 0, and here you've got 0, negative 1. Okay, so this x you can think of cosine, y you can think of sine. Okay, all right. So you definitely want to go ahead and plug in these two endpoints and find out if they're equal. Okay, if that's the case, then what does Rolle's theorem ask you to do? Is you want to check if you have f, right? This function, is it continuous? Okay. And of course it is. And what's the other thing? Again, specifically on the closed interval. Okay. Next, you want to check that if your function, what? You guys can pause the video and look, right? If it's differentiable. And of course it is on the open interval. So then, with that criteria met, we know that Rolle's theorem does apply. Okay, so we can say RT applies. All right, and what does Rolle's theorem basically guarantee us then? It assures us that the tangent or the slope, essentially, right, of our function sine of x, which is cosine of x, what about it? Okay, you can again pause the video here and see where I'm going with that. But it assures us that we will get it to equal to 0. Okay, it's guaranteed. So what we want to do is investigate where that happens. And again, by looking at our unit circle, we know where do we have cosine equal to 0. Okay, we have it at, this is 0, this is pi, this is 2 pi. So if you take pi and cut it in half, that's pi halves. And then that's 2 pi halves, 3 pi halves. Okay, so it happens at x equals pi halves and 3 pi halves. Okay, so therefore we can conclude that C equals those values. Okay. Now, of course, there's infinite amounts, right? We can go pi halves, 3 pi halves, 5 pi halves, 7 pi halves, but we're supposed to work within what? This closed interval. Okay. Well, if you have questions or comments, we'll address them in class. Let's go and continue. Okay. Okay, here we have a similar situation. Okay, and I wanted you guys to see the other side of this. It reads like this: determine whether Rolle's theorem can be applied to f on the closed interval AB. If Rolle's theorem can be applied, find all the values of C in the open interval AB such that f prime of C equals 0. Okay, so we're going to go ahead and pretty much start off the way we did on the last exercise. Okay, so we're going to go ahead and plug in f of 0. And we're going to investigate if it looks like f of pi. Okay? So, again, you'd have to look at the unit circle. Again, I love these trigonometry problems. That way it forces us to review them together. Okay? So, if we look at it, let's go and label it again. 1, 0. 1, 0. And if you're awesome with this, good. If not, just take time, look at the unit circle, and try and retain a lot of those properties that you guys used back in pre-calculus trigonometry. Okay. All right. So if I was to plug in 0 to tangent, what happens? Well, tangent, okay, of x is essentially cosine, or excuse me, sine of x over cosine of x. Okay, so what we're going to pay attention to is at 0, okay, we would basically have what? 0 over 1. Okay, so that's 0. And when we plug in pi, okay, we would have what? Sine 0 over negative 1, which is 0. Okay, so we do have that criteria met. So now where do we go from there? Okay, is f continuous? You can pause the video, kind of decide for yourself. Okay, so here f you should have found is not continuous, okay, on 0, the closed interval pi. Now what I would encourage you guys to do is graph it to kind of look at it. But what happens for f not to be continuous? Okay, something special happens here. Okay, so let me make in quotations. At f of pi halves, okay, I'll put an exclamation mark there. Okay, again, you should pull out the graphing calculator, kind of check that out yourself. But let's go to pi halves. Pi halves is here. Okay, so if I was to take my sine, which would be 1, and divide by cosine of x here, which would be 0, it'd be undefined. Okay, so it is definitely not continuous. So we have not met the criteria, so therefore Rolle's theorem does not apply. Okay, alright, so we've got to look at one of each. Let's go ahead and move to this next and last case. So this one involves the mean value theorem, which you will have read by the time we get here. So it reads, determine whether the mean value theorem can be applied to f on the closed interval AB. If the mean value theorem can be applied, find all the values C in the open interval AB such that f prime of C equals f of B minus f of A over B minus A. And then we're given f of x equals sine of x in that interval, specifically closed interval, 0 to pi. Okay? Alright. So basically, as you guys have read, if we're going to be able to apply the mean value theorem, essentially we're guaranteed that the slope of the secant line matches the slope of the tangent line. Okay? If you picked up on that, good. If not, that's all that's happening here. Okay? So let's go through, do we qualify? Can we use it? Okay. So f, is it continuous? Okay. You can pause the video here. And it is. Okay. Definitely is, but definitely in this closed interval. So that checks out. And next, you can pause the video here, and what's the next thing we got to check? Okay. Is f differentiable? Is it differentiable on the open interval? It is indeed. It is differentiable, of course, and most definitely on the open interval 0 to pi. Okay, so then what does the MVT tell us? Okay, it tells us that we definitely will have the slope of the secant line match the slope of the tangent line. And if you're thinking tangent derivative, good. Okay, you've got to allow yourself to make those associations. So let's go ahead and see what the slope of the secant line is. Okay. Again, here we have on this side the slope of the tangent is equaling the slope of the secant. Okay. So let's do this part first. F, what are we told to plug in? B, right? And we plug in A here over B minus A, right? Straight from the formula. This, once you evaluate it, gives you what? 0 minus 0 over pi. Okay. So again, how do we know that? Because sine of pi is what? 0, and sine of 0 is 0. Okay. Alright. So therefore, the secant line has a slope of 0. Okay. Now that we know this, this should equal this. Okay. So let's go ahead and take f prime of x. Okay, which is, we know that to be what? Cosine. We know should equal, right? This is, excuse me, this is the formula for slope for sine of x. Okay, and specifically we know that the slope has to equal 0. So where does cosine of x equal 0? That's at what? X equals, that falls in this range, it would be at pi halves. Okay. Again, if you've got to draw these 1,000 times, do it. But I'll just draw a part of it. This is 1, 0, and 0, 1, right? And the interval we're talking about is from here to pi. Okay, so it happens at pi halves. So just like the MVT guarantees this is occurring at c equals pi halves. Okay, this section is a little intense. Okay, but that's what we signed up for, and we're going to be just fine. We'll continue in class. Okay, see you then.